Hello everyone. Let me start by welcoming you to our webinar this afternoon, and thank you for giving us your time from whatever time zone you happen to be in. My name's Gordon Ellis, and I'm going to be talking to you about our maintenance optimization process and how we can get that to actually achieve the right balance of work. So for those of you who don't know me, I will start by introducing myself. And I've got the focus on the wrong screen here, which is why my slides are not moving on. Bear with me 2 seconds. So I'm the maintenance and reliability team lead with Vysus in the UK. Vysus being formerly Lloyd's Register. I've been with Vysus around 2.5 years, but my industry experience has always been in similar roles, working for service companies in oil and gas and energy sectors in maintenance, condition-based maintenance and condition monitoring. So a little bit about who we are as Vysus. So in November last year, LR had a strategic carve out of what was at that time the energy division, and we became Vysus Group. We're a leading engineering and technical consultancy offering specialist asset performance, risk management and project management expertise across complex industrial assets, energy assets, oil and gas, nuclear, renewables, energy transition, rail and road. And we have a number of teams, and myself, I'm part of the asset management consulting team. We have a risk management team, survey and geoengineering, well, project management, engineering and operation, module spec, power engineering and grid connection. And if you ask me any questions on these, you will find that there is a question panel that you can type your questions into. You can only listen to me, I'm afraid, but if you type your questions in, I'll come back to those at the end of the presentation. But if you ask me questions on any of the other services, I'm afraid I'll need to phone a friend and get back to you after the webinar. So, as Vysus Group, we have a legacy going back to the 1930s when LR Energy formed. We have grown over the number of years with acquisitions with companies like Capstone and ScanPower joining, and that continues. Earlier this year, we actually acquired a company, ProMaps Technology, which is all to do with power stabilization. So we're continuing to grow and expand. All of the people who were with LR Energy and all of the services that we had came with us. So for all, we're a new start. We can claim an 80+ year heritage from our background. Not going to spend long on this slide because I don't know much about all of it, or I'm not an expert in all the service lines. But again, just to reiterate some of the areas that we do in the asset management consultancy: drilling rig integrity, compliance, survey geoengineering, grid connection, energy transition, engineer operations and project management, and risk management as well. Okay, those of you who have seen anything that we have published on the maintenance optimization, or you may even have seen my very short video on it that we have available on our website, will know that we actually get some pretty impressive results. And I'm going to just start by going through just a couple of case histories to remind people of some of the stuff that we have published in the past. So we did some work on an FPSO for some maintenance optimization. We looked at some 5,000 planned maintenance activities over a 6-month period for a 7300 type FPSO. We actually looked to determine revised maintenance intervals. We had a validation workshops for those, held with offshore and onshore personnel, prior to actually updating the routines and Maximo, the CMMS that they did. The results of that gave a net reduction of planned maintenance of over 40%. We incorporated the classification society requirements and additional planned maintenance introduced for production critical water injection equipment to fill some gaps that we picked up. For another client, we were focusing on their electric motor maintenance. And here we were actually looking to see which items need to be maintained, which could be run to failure with minimal adverse consequences. And again, we use software tools to provide optimized maintenance intervals for the low voltage population and they took 3 weeks and included 970 motors. So the output of that was an estimated cost saving of 65% made in annual maintenance on the low voltage motors, reduction of around 7,000 annualised man hours, and then we also made some recommendations in relation to their greasing routine going forward to help with the reliability of the motors. The final example, fire and gas maintenance review. We looked at a total of 7,500 fire and gas detectors, and we had over 8,000 work notifications to determine the reliability of devices. Maintenance was then targeted according to the reliability performance based on the detector type and facility. And the savings that we got with that were a planned maintenance reduction of 26%, with an estimated annual saving of around £385,000. The advised maintenance was applied to ensure that specific reliability targets were able to be met, and the maintenance effort was refocused in the areas of greatest risk for the client. I'll just remind everybody that these are annual savings of £385,000. So it's not a one-off payment. It actually continues to provide those benefits year after year as long as your plant is operating. If you take that to a corporate level, we did one review for a major operator in the North Sea. Across all of their assets, they had an annual planned maintenance of around £100 million of OPEX and 390,000 man hours a year. We looked at a number of key target areas from their systems, looking across their metering, inspection, valves, pumps, motors, etc. And we identified savings of around about 74,000 hours and around about £22 million of OPEX to actually reduce their costs. So as I say, some pretty impressive savings can actually be made by going through these types of processes, but you don't actually always have to start right at the deep mathematical side. So just showing a slightly different example here. This was for a North Sea operator looking at a number of their safety critical work instructions on an FPSO. And then identified that they had around about 624 was their initial starting number of work instructions. But actually, in fact, when we dipped into those to review them, we found that there were around 286 of those that weren't actually SCE. So that was leading to an incorrect focus and prioritization of work. This work was being treated as SCE when it actually had nothing to do with meeting the assurance standards and the safety function. So that left only 338 work instructions. However, going through the ones that weren't identified as safety critical, we found another 125 work instructions that should actually have been categorized as safety critical, and we identified a gap which needed filled with 17 new SCE work instructions. And of course, that really represented a fairly significant unmitigated risk for the asset before we did that. So what we achieved overall was a 23% reduction, but in actually reducing that amount of maintenance, we also managed to reduce the risk for the asset was subject to, and actually improve the prioritization of their work going forward. And that was all just done with a sort of review, deep dive into their actual assurance activities, the performance standards, and the related work instructions, just to make sure that they were addressing the correct areas. So what are we trying to do? So the ultimate aim is to actually do the right thing, maintain the equipment in the right way, at the right time, so when it needs it, and do it right first time and safely. So when you're actually looking to do your maintenance optimization, these are some of the questions you might want to start with. So how often should your maintenance tasks be conducted? Should you be doing it daily, monthly, every year, every 2 years? Well, who actually determines that? More importantly, how is it justified? And in that justification, are you actually setting the grounds to be able to drive continuous improvement going forward? and improve things forward further. It's all planned the same, and of course, where do you actually get started? So hopefully I'll answer some of these questions in the next couple of slides, where we're demonstrating how we actually make the decision of how we do when we do the maintenance, how it's justified and recorded for continuous improvement going forwards. Other aspects you might want to consider include things like, how do you minimize disruption to your production manufacturing process? Where can you replace intrusive maintenance with condition monitoring? One of the topics very close to my heart. How do you do the optimal frequency and duration of your intrusive tasks and condition monitoring? What potential overlaps do you have in your plant between, for example, your operator checks, pre-use checks, and standard weekly monthly schedules? So if every day the operator goes out and checks the oil levels in the crane before you start it up, are you really getting much benefit out of doing a monthly check on that? But you are definitely getting a benefit out of doing a condition monitoring oil sample task. So it's just making sure that you're making best use of the routines that you've got to credit them against maintenance activities that may not be required. Then, what optimal level of spare parts do you require? And where is it held, and how do you maintain the spare parts themselves? Really important part is making sure that you've got effective work preparation, so that when you do go to do the job, you can get started straight away. We obviously want to avoid maintenance-induced failures through precision work execution. We want to make sure that we've got accurate recording and maintenance history, because that's what we will base our decisions on going forward. We want optimal type and number of resources, and we want to determine an optimal level of OPEX budget. So to answer the question, where do we start? Where we normally start is with what we call a facility analysis, which is a high-level overview of the distribution of your program, your scheduled upcoming PM work. And we've got a unique way of drilling down to represent and displaying the CMMS content, and it allows us to quickly identify improvement opportunities and look at how we can focus our effort going forward. So it really consists of a process of data manipulation, getting the required data from your Maximo or SAP system, your PM tables, rootstops, etc., and process it into a format for review. We then go through and we categorize it by what is being maintained and who is doing that maintenance by discipline and interval. We then have an engineering review of data to identify opportunities, and then we sit down and we present and discuss the priorities with our actual clients. And we have a number of ways, having gathered all the data and actually pulled it together, we have a number of ways of slicing and dicing it to help determine what is the core focus for the asset and the client in question. We may, for example, want to look at the maintenance hours by focused equipment system. So how much time are we spending a year on our cranes, on our fire and gas detectors, PSVs, etc. Or the issue for the plant might actually be that they know they've got too much instrument maintenance, which is very unusual, of course. So we can actually look at discipline. We can look down to see, who's spending most of the time. And if, for example, it is the instrument techs, we then know to focus the review on the instrumentation routines. Finally, here I'm just looking at showing it actually by the interval that the task was conducted. So in this particular plant, we found that 24% of their annual hours was spent on routines that were generated monthly or 2 monthly or 3 monthly or less. And again, that gave us a clue as to where to go and look and start to see what we could actually improve. Having determined the actual what we are going to look at in terms of the optimization, we'll really get 2 ways of doing it. The first that I'm presenting here is a target optimization, and this tends to be used when we're looking to define an equipment test interval to meet either an agreed reliability or availability target, and is used predominantly for safety systems such as fire and gas detectors, emergency shutdown valves, safety instrumentation, PSVs, etc. And the calculation inputs that we have is our current test interval, our reliability or availability target, and our equipment failure rate, preferably calculated from the actual asset itself. That failure rate has, of course, to be relevant to the task that we're actually optimizing. So say, for example, if I take the example of PSVs, we actually test them to look for them failing to open on demand in the dangerous failure mode. So when we're actually doing the analysis of the failures over its operating history, we're actually only looking at dangerous failures where the valve failed to lift during a pop test, not leaks and air lifting at low pressure, because that's not what the test is looking for. And what we get out is a nice little graph showing us our sort of optimized test interval, and a bit of sensitivity analysis to show us where the actual, if we're a little bit out in our failure rate, for example, the effect that would have on our results. The other way that we have of looking at the optimization is cost optimization. And that tends to be suitable for things such as our electric motors, our pumps, instruments, centrifuges, compressors, fans, etc. And what we're doing here is we're determining the balance between direct maintenance costs and the risk cost, for example, the cost of doing your maintenance versus not doing, to look for the lowest cost of ownership. So again, the inputs for this are the current test interval, our cost of actual maintenance, which includes our hours, the man-hour cost, the materials, and any production loss associated with shutting down the equipment to maintain, our equipment failure data, including the failure rate, and then the cost of failure in terms of hours, materials, and production loss, again, should the machine fail. And what it does is it does a sort of algorithm in the back to run a simulation of your costs and works out your best balance for your maintenance interval to reduce the costs. And again, we get some sensitivity analysis with this as well. So I've spoken about failure data a number of times. Obviously, for our failure rates, there are a number of published industry reliability data sources available. But the best way to actually optimize your plant is to actually use your own operational data. So the process that we would go for that, again, is to look at an extract from your CMMS, your work order history, including long text, process into a format for review. We then do a fairly deep dive into it. Failure codes we find give guidance, but they're really enough to actually do the full identification of what has failed and why, for various reasons. But that's a separate subject in its own right. We then calculate your failure rate, again, based on our relevant failures and operating time. And going back to the PSV example, if I'm actually looking for dangerous failures, extracting them from your pop tests and certificates is actually relatively straightforward. It can be a little bit time consuming, but it's not particularly difficult to do and can give results quite quickly. Side process of what we're doing identifies bad actors, but don't do maintenance optimization to actually resolve bad actors. They need a different process. I would suggest it needs to, starting with a detailed root cause analysis with your bad actors to work out why they're going wrong, because optimizing the maintenance very rarely will actually solve anything for them. So, in summary, before I go to questions, savings quoted at the start, talking around about 27 million achieved for one operator. Sounds like a huge amount of effort, but actually by doing what I've just demonstrated, by actually doing the facilities analysis, by focusing on the effort, and actually to some extent focusing the ongoing project from savings from the initial low-hanging fruit, we actually saved that £27 million with a 10-month project at a cost to the operator of around 200,000. And these were on assets that have been operating in the North Sea for quite some while, and have actually been very successful in reducing those costs. Okay, I'm just looking to see, do we have any questions coming in? That's actually the end of my slides. No, we have no questions. If you do think of any questions after the event, please feel free to contact us, and we'll happily get back to you. But in the meantime, I'd just like to thank you again for your time to listen to us, and much appreciated. And I hope the rest of your days goes well. Thank you.